Yes, now we are recording. Okay, so here I am going to create a new environment, right? Conda create -n, right? TFlow. Okay, and I want all the packages that come with Anaconda. And then I want Python 3.8. So this is the command. When you click on it, enter, right, it will. The fresh installation this is. I need to copy code here, I think. Yeah, I need to copy the code and do that. So I'm installing all the software. Then I'll install the TensorFlow GPU. Okay, so this environment is installed, right? Now we need to activate it. See, Conda activate, TFlow will activate, right? So when we install something here, Conda install or pip install, right? That gets installed in the base environment. Wherever the no, this is not the Anaconda base, but base environment it gets installed. To install or open Jupyter Notebook from the particular environment, you need to activate it. Conda activate TFlow. That's the name I have given. You can give any name for the. See this here, it's changed, right? TFlow now. But if you say Jupyter Notebook, right? TFlow from Jupyter Notebook from TFlow environment will open up. Okay. Before I install the TensorFlow, right? I'd like to see whether the GPU is identified or not. There is a command to check. Give me 1 second. I forgot the command name. Kuda CLI, I think I forgot. Yeah, SMI, NVIDIA SMI, NVIDIA, NVIDIA SMI. This is the command to show, right, whether the GPU is installed or not. See, I have a GPU with almost 8 GB RAM, right? 8 GB RAM and whatever 300 MB is used right now. And then processor. Yeah, the drivers are also installed here. So I am just checking whether NVIDIA drivers are installed or not. If NVIDIA drivers are not installed, right, even when we install the TensorFlow GPU, it will not get, it will not be using the NVIDIA GPU to execute the project, execute the code. So here, let me install Anaconda, that TensorFlow GPU. Let me try to look for install. So sometimes, right, when you install Anaconda command, it will install older version, not the latest version. So on Ubuntu, it is installing 2.2 only. When you go to this website, right, Anaconda website, it will show you what is it doing. So let me try Conda install. Okay, I am installing TensorFlow GPU. For you, it is going to be TensorFlow only. When you don't have NVIDIA graphic card, it is Conda install TensorFlow only. And on what you call it as Collab, right? It is already installed. It is already there. You can just open up the what you call it as Jupyter Notebook and play with it. Okay.
So both TensorFlow GPU and TensorFlow are installed, right, when we use the collab.
It is already there. It is GPU version is going to be there. By default, Collab will assign some GPUs when you start executing projects. Selection 2.2.
So to install the TensorFlow on GPU, like we need Linux is a OS laptop is required, sir. Windows does not support.
Windows will support, but all the modules that we want to execute are not going to work on Windows machine. TensorFlow GPU or TensorFlow will get installed on Windows, but when you try to do some work on NLP and computer vision, those modules will not work. Got it?
Okay, okay.
There are YOLO 3 and other algorithms, and in NLP, right, Flare is one module which is built on which is character based CNN RN models they are. So those models, right, when you install, right, it asks for Visual C++, and that too version 14 or something, and then you need to find it and install, and still it's not going to work. I struggled a lot with it, but
Okay.
on Windows, trying to do computer vision and NLP using deep learning is not that convenient. So if you see, yeah, I answered your question, right?
Yeah.
So you see, TensorFlow, it is installing 2.2, but the latest version is 2.3, right? Why am I showing this is on Collab, right? It will use 2.3. Okay, on Collab, somehow they installed 2.3. Maybe they used pip to install, right? You can install this way, or you can open Jupyter Notebook, and from there you can install, pip install also. Okay, so this is one way. If you say yes, right, it gets installed. So this is one way. So I'm not going to do this way. I'm going to open Jupyter Notebook and see which version it is installing. See this here? I see TensorFlow 2.2, it is getting installed. Okay, Conda. Because Conda command has got our Anaconda integrated 2.2 only. Okay, I'm not going to install this here. I'll see, what happens if I do pip install. I can do pip install here, right? Right, GPU. Like this I can do, or I can open Jupyter Notebook. So multiple ways of installing this Anaconda, sorry, TensorFlow I'm trying to show. So I need to copy that whatever, but here let me try to take a some folder, right? New tf install test. Some test, okay. So here I am saying exclamation pip install. So I did control enter. See, it is installing TensorFlow GPU 2.4. No, even latest version is there. I thought it is 2.3 only. Right? When you install with pip, right, it is installing latest version. Why am I telling you this is? You may build something on Collab, and Collab uses some version of TensorFlow. On your local machine, when you are installing, or in a server you are installing, you should make sure that the same version is there. Rather, the training or the model you saved may not work on your local machine or the dev server or the no production server. Got it? Version incompatibility is a big issue when you build models and trying to migrate in deep learning. So you need to make sure on the cloud environment and your local machine or the cloud environment where you are trying to build, you need to make sure that all the versions are same. Okay, to make sure that you need to use appropriate command. It is not always good that you use conda. It is not always good that you use pip. You need to see which one actually is compatible with what. Got it? Got it?
Yeah, yes, sir. But when we install by default using the Conda, all the libraries will be installed, right? The latest libraries.
Yeah.
So if we need a specific versions, we shouldn't use that command and individually install all the required libraries. Is that right?
For deep learning, it is always suggested to deep learning and OpenCV. Installing them individually, the needed version is suggested or preferred.
Okay.
And for not all, for these deep learning and deep learning packages and OpenCV. There is a concept called requirement file in Python. Okay, you put all the needed versions, of the packages you want into a txt file called as requirement.txt, right? And then you say pip install -r requirements.txt. Let me show you one. No, see, your question, right, Seshiram garu, your question is like, I installed Anaconda that gives me all packages, but do I have a way to install the other modules which are needed? Only the versions I needed, right? Is there a single way? Huh?
Yeah.
So there is a concept called as requirements.txt. Somewhere I'll have. See this here. See, these are all the requirements. Okay. So these are all the modules it's going to install. These are commented. Hash is commented, right? Sorry. Hash is commented, right? So those which are not commented, those versions we are installing. So this is greater than or equal to. Some modules greater than or equal to, some modules equal to only I'll give. Right. So when I say pip install -r like this is the command. At the command prompt, go to command prompt, right? Go to the folder, go to that particular folder and type this. It will install all the modules specified in this requirements file. So this is how you can maintain the the versions, right? The version numbers uh, in different environments. So you are building something on your dev environment. You need to make sure all the versions are documented in requirements.txt. And when you are migrating code, right, you take this requirements.txt and try to do this pip install or requirements.txt. So when you have virtual environment created, this requirements.txt will make sure that all the modules are installed in that virtual environment only. Okay, but there are some exceptions in Python. It is not that easy. When you install OpenCV, right, or the NVIDIA GPU drivers, it will actually not getting installed in one environment. It is actually overlapping between multiple environments. Sometimes what we were doing is we try to install a new module which is getting conflict with other modules, so we have to wipe out the whole operating system and we are installing again, OS and the new environment again. So that those are all the troubles when you actually do coding, right? But for now, right, virtual environment keeps all the modules separate, and we opened a virtual environment and inside it we are doing pip install, right? So let me show you the version that we are using in TensorFlow. Let me check. There is a command for that. Give me 1 second. So I thought of covering what you call it as PyTorch also for this batch, but couldn't do it. We'll try. We still have time, right? So tf underscore tf dot underscore. See that this is the version. Okay. So now what I'm trying to show is, let me open a terminal. Right here, this is not the base. This is not the TFlow, virtual environment. TFlow virtual environment is this one where we actually install TensorFlow. Now I am going to open a Jupyter notebook from this command prompt. Right. This is a not TFlow one, right? So I'll go into documents and create a new file, or I'll open the same file and try to run that. See this here, I am commenting this out. Okay. So I'm not installing anything here. So and then I don't know why I did not save it, I think. That's okay. That's okay. So here, I think I can copy paste it, right? I would have saved it, that would have came here. See that? No module. Do you observe? Right? The Jupyter notebook I opened from base environment, right, has no module TensorFlow. But the Jupyter notebook, right, Jupyter notebook, I opened it from the TFlow. It has got 2.4. Do you see the difference? Use of virtual environment?
Yeah.
Right. So it is pretty much needed, right? In every project, you need to create virtual environments and play with them. So try to practice a little bit in that direction also. Even on your Windows machine, you can create virtual environments. You can install TensorFlow. There is no problem in installing TensorFlow also. But when we do computer vision projects, right? That's when either you need Ubuntu or Collab. The Collab paid version is $10 only. I think if you explore it more, you may know. But $10 a month is not a big deal. So to practice for maybe 1, 2, 3 months, right? It's not a big deal. So you can try that out. Okay. So that's it. So that's about the TensorFlow installation and how we want to play with it and things like that. Right now, I need to start that presentation. Give me 1 second. I came into this Ubuntu environment, right? I need to copy the content to show you some coding, some programs on building some models on TensorFlow. Give me 1 second. See, yesterday I said I am going to use Ubuntu, but I forgot to actually copy and all that. Give me 1 second. Okay.
Sir, it looks like the Collab Pro is only available in US and Canada.
Okay. Not in India.
It has actually given a note under the settings we have seen yesterday, right?
I did not. I did not explore it basically. I just looked at it and asked you like maybe. MSI. Give me 1 second, okay. I'm just trying to find the folder here. Google Drive training should be there. Okay, let me download it from Google. Give me 1 second, okay. Let me download only that particular part. Okay, I have it. Now let me go to downloads. Okay, so I'm going to use Datajango as a dataset only, and I'm going to show you the two means, TensorFlow 2 version. Previously, I used to have 1.14 version and 2 version and all that. Okay, so let me do one small thing here, and then I'll start explaining. Okay, so okay. So I imported TensorFlow as TF. You can see the screen, right? Should I expand a little bit? Give me 1 second. Okay. So I imported TensorFlow as TF and pandas and NumPy, right? Shift enter and then version changed. When version changes, right, some of the behavior will change in TensorFlow. Basically, TensorFlow gets updated every 3 months or 2 months. You write some code now and you close it and open it after 1 month and execute, right? The behavior will change. There will be some deprecated methods and all that. Okay, don't get surprised if you see some deprecation messages and things. Right, so I have downloaded that digit recognizer dataset. Oh, that is the shape. And I have taken digit recognizer because the data set no need to do anything there. It is all clean. We need to understand how to build a deep learning model. So I looked into head, the columns, and I split it x y, the same thing, right? Where we the scikit-learn and the TensorFlow are kind of follow the same protocol in a way, right? So x and y we split it, and then train test split, right? and then standard scaling. We are doing standard scaling because deep learning also uses the gradient descent algorithm. When you are using gradient descent algorithm, all features should be on a similar scale, right? So I'm applying standard scaling on the train and test. Now this is the TensorFlow model. TensorFlow, the Keras is an API, right? I think I have already told you that application programming interface API means documentation explaining how the methods are written, right? That is one meaning of API. The other meaning is somebody would API specification would say, we'll say Keras as a specification. I think I don't know whether you know it or not, but servlet specifications. Do you know servlet 2.3, 2.4? Right? Have you heard about servlet specifications? Yes, no.
No, sir.
Yeah, servlet specification means when you are, when we were building web application in the initial stage, right, 2000, 2002 time frame, some organization actually defined the specification of how a servlet should be, right? What is a servlet and what it should do, how the method should be, how the functions should be, how they should take input and how they should, return the output. So that time, the servlet used to written a HTML code, right? So that is specification. So somebody like, suppose that I defined a way to write a document, right? You are actually trying to build a program to write that document, right? Something like that. Keras is a specification, and deep learning frameworks like TensorFlow, PyTorch, right? These frameworks are actually trying to implement that specification because they are trying to bring a uniformity to all the different modules, deep learning modules. But most recently, with TensorFlow 2.0, TensorFlow actually embedded Keras into itself. Okay, in a way that their TensorFlow is implementing Keras specifications. Along with that, TensorFlow is adding more code or more sophistication to Keras specifications. So you will have TensorFlow Keras in some places, right? You will have like this, right? Import Keras as K, right? Sometimes you will find this kind of a code. This is like individual Keras is also there. Individual Keras by default uses the TensorFlow as the backend. I suppose that I am not confusing you. Keras is just a specification. Specification means what the method should do. What individual methods you should do is explained or is written in Keras, right? If you install Keras, by default, Keras will install TensorFlow as the backend because Keras has no code for itself. It is just a specification. It will have the skeletons of classes and functions. When you install Keras, right, it installs TensorFlow and uses TensorFlow as the backend. Okay, so you can use this way, but after 2.0, after TensorFlow 2.0, no need to use Keras because Keras TensorFlow, took whole Keras, adapted it and implemented everything. On top of it, it added more sophistication. Got it? From now on, whenever you see Keras code, there is no need to use Keras code. You can actually transform it to TensorFlow Keras. Got it? Difference between individual Keras and TensorFlow Keras? Difference between TensorFlow Keras and Keras, you got it?
Yes.
Yeah. So in old code, right, you will see Keras. Even in our code examples, right? Maybe in the RNN I have used Keras only. So by default it uses TensorFlow backend only, but there will be some differences in signatures, method signatures and all that. There will be syntactical differences. Okay. So in Keras, in TensorFlow Keras, there is a class called a sequential. Okay. And there are layers like flattening and dense layers. So what is dense layer? We need to understand. So here I am saying model is equal to sequential. Right? In this model, I have added a dense layer with 16 nodes with activation function relu. Okay, let me try to. Again, I may not be able to draw it here. Give me 1 second. See, when I change operating system, right, it's all new thing from scratch. So give me 1 second. Let me connect my pen. So I am trying to implement a neural network. Not this is easy. This is not a big deal, but due to my unpreparedness. Yeah. So I can take a screenshot here. Yes. Give me 1 second. I need to take a screenshot here. Okay. Took a screenshot, but the screenshot is. Yeah, I got it. So here. So this is the network we are trying to build, right? So. Oh. Give me 1 second. I forgot the software that makes me write. Give me 1 second. Give me 1 second, okay? Sorry for the inconvenience. Now, Paint softwares and Ubuntu are there, right? Paint. Pinta. Sorry, got it. Okay, now the screenshot, I need to open it in the printer. So here, right, we are actually trying to, this is a network we are trying to build. Okay, so this network is like this. So I am passing 784 pixels, x1, x2.
Sir,
Yeah.
so when we install TensorFlow normal or TensorFlow GPU, we just say import TensorFlow. Is that right?
No, import TensorFlow will install normal TensorFlow. TensorFlow dash GPU will install TensorFlow GPU.
No, importing. Installing is fine. Importing. When we import the
Importing, yeah, same TensorFlow only. No GPU needed.
Okay.
Yeah, that's a good question. Sorry, I was, yeah.
Yeah, okay. No.
X2 and so on, X784, right? These are the pixels. And then in the first layer, I have got 16 nodes, right? 16 nodes are there. In the second layer, I have 8 nodes. In the third layer, I have 4 nodes, right? In the fourth layer, right, if you see this here, I have 10 nodes, 10 nodes, and softmax is the outcome. Softmax is the activation function. Why I did this is, in our digit recognized data set, I need to recognize 10 classes, right? 0 class, 1 class, 2 class, 3 class, and so on, 9 class, right? So for 9 classes, 9 nodes in the output layer. So these all are going to go like this. Right, like that. So this is the network we are actually trying to build using code. Okay, like that, right? So this is the sequential model, which actually creates a simple neural network. This I call it a simple neural network. There will be complex networks. I'll show you in coming classes. Right? So we are adding a dense layer with activation function ReLU. If I don't specify ReLU, right, it is just a linear combination. Right? If I don't specify activation function, if I say model dot add and then dense 16, that's it. If I say, right, then it is going to be linear, these 16 are going to be linear combination only, linear regression. Okay, if I say ReLU, right, it becomes a non-linear function, and hidden layer should be non-linear function. So there are, so we are adding, this layer we added, this layer we added, this layer we added, and this layer we added to the sequential model. Okay, that part is clear, right? That part is clear, right?
Yes.
Yeah, now we are actually creating an optimization objective. This is called as optimization objective. That SGD, stochastic gradient descent, is the optimization. So there are different optimization objectives here, optimization functions. SGD, momentum, RMS prop, and Adam. These are the 4 objectives I am going to explain. There are new variants of these came in most recently, but knowing these 4 is good enough. Okay, so SGD is the optimization objective, and learning rate is 0.0. Do you remember what is learning rate in gradient descent and where it helps? Learning rate helps in Overfitting, reducing overfitting or converging fast?
Conversion.
Yeah, convergence, right? So whether the model is converging or diverging, based on that, you need to play with this. Okay, and then you need to compile the model. When you compile the model, right, it will actually create that whole structure. This whole structure along with the optimization objective. Right? Optimization objective is nothing but no, yeah, optimization object is the way we are trying to converge towards the global minima. While compiling, you specify the loss function or the cost function. Now, sparse categorical cross entropy and categorical cross entropy, two loss functions are there. If you are using sparse categorical cross entropy, the y variable should have only one value, right? For each record, there should be only one value. Like in our digit recognizer, for every record, there is one number only, right? Either 0 or 1 or 2 or 3 or like that, right? If that is the way, you should be using loss function is equal to sparse categorical cross entropy. No, if that is not the case, right? The other case is going to be, right? You have x1, x2, and so on, x784, and then on the y variable there is 0, 1, 2, 3, like that. 9 classes are there. If the first record belongs to 1, right, you'll put 1 here, rest all are zeros. If the second record belongs to 2, you'll put 1 there, rest all are one hot representation of y values. If you have one hot representation of y values, then you should be using categorical cross entropy, no sparse. Got it? So loss function, loss function is dependent on the way we represent y value. If the y value is having one number in there, then we should be using sparse categorical cross entropy. If y value is having a one hot representation of the existing y, then you should be using categorical cross entropy. I'll show examples in future, but I'm just trying to dump what I know now, right? And then metric is accuracy. We are using accuracy here.
So is it not reverse?
Yeah, it is reverse actually. In our thought process, right, it is reverse. But
Yeah.
I don't know why they took this way. It actually works like that only.
Okay.
Yeah. It is a sparse representation, right? Sparse categorical
Yeah, when
cross
it is one hot encoded, it's a sparse.
sparse matrix actually. But I don't know why. Must be some reason, but I couldn't understand. Even I get confused when I see that. Okay, I'll show you one example with sparse categorical cross entropy also. Not normal, whatever. Right now here, metric we are going to take is accuracy. So when the loss function is trying to understand the model, right? It will use accuracy as the metric to to optimize the weights. Okay. Now we are fitting. When you say fit, right, that takes the data and then number of epochs we specify and the batch size also is specified. Here we have everything in a data frame, so we are able to specify our numpy array. So we are able to specify the batch size. But in some cases, right, you will have data in a file or a database. In that case, right, batch size you cannot specify like this here. You need to write code to create batches of data and then pass it cumulatively. I will see that also in coming classes. Okay, that is the way to build a network, and let me try to execute this a little bit and show you. Right, now I am constructing a network. Right, this is called as construction phase. Right, this whole thing is called as construction phase till here. Right, now it is execution phase. Right, fit is the execution phase. Okay, in neural network, in TensorFlow, this is called as uh, computational graph. We are constructing a computational graph. We built a network. We we compiled it. This is when it creates a computational graph. When you fit, right, that's when it starts executing it. Okay. So till that point, nothing happened. From here, it will happen. See that accuracy is improving, right? Step by step, accuracy is improving. if suppose, right, if I take and then I took up learning rate is 0.9. What is happening there? Model is not changing much, right? That means no, there is some problem with the learning rate. It is not converging. Okay, then you need to reduce it. Okay, if you reduce it too much, what happens? Still it is learning, but the learning is very slow. See that the step size is very slow. Accuracy is not improving much, right? If I take zero point 0.1, I think 0.1 will work better. So same, whatever we did in the gradient descent is what we are doing here. See this? Right, with 10 epochs we have got 94. If we increase the number of epochs, right, it will increase the accuracy more. The other way is that you can actually increase this learning rate also. See that what happened here? Can you tell me what happened here? When I made 0.2 the learning rate, what happened? Guys.
Variations are too much.
No, not
Yeah.
variations. If you look at the accuracy, right, you will be
Yeah.
able to understand what
Yeah,
happened.
that's what accuracy and variation is too much.
Yeah, what happened here? It actually suddenly dipped, right? From 86 to 10% it dipped, right?
Yeah, it converged to some extent and then went
Started
into
diverging.
went into opposite direction. Yeah.
Went into opposite direction. I know on that I know that in your that curve, right? It actually took 2 steps in this direction, then it started diverging like that. Okay, so that's the case, right? So same whatever you concept you understand there, the same thing will be useful here. Okay, will not do much. And with 1.1 and 0.2 is the area where you will have best hyperparameter, right? 0.1 and 0.2 is where you will have best hyperparameter, because with 0.1 it was converging good, with 0.2 it converged a little bit and then it jumped, so maybe in between it is there. Or you can actually increase number of epochs also. If you increase number of epochs to 20, then also the model may give more accuracy. It is running fast on my machine because it's a GPU one, right? If it's on your machine, right, it may not run that fast. So let me show you how the GPU resources are being used. That we are executing this. Okay, so let me execute this. Whoa. Ah, sorry. 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 Let me go back to the code. Let me run this again. Oh my goodness. No. By the time, let me try to run this again. Maybe I'll run all, kernel restart and run all. That way I'll get some time. You'll see a change. It is not using, see this GPU, 33% it is using. See this, see GPU utilization. Right, it will drop. See 17%, 4%, right, 6%. And that 5%, 6% is used to show the UI, right? The desktop and all that, whatever other graphics it is using. But when you say 33%, right, that's when the model is getting executed. Right? GPU is being used and model is getting executed. If it is on CPU, right, it will not run this fast. This model may take, maybe 10 minutes or so. Here, within 1 second, this whole thing is getting executed, right? So that is one thing, right? And if you see this, right, when I execute n number of times, n number of different things are happening here. See this here, diverged again, right? So this is not a safe learning rate. Maybe that is a safe learning rate. And if you give more epochs, right, it will be consistent only. So 20 epochs, right? 20 epochs, we have got around 94% accuracy, right? 95, 93, 94%, right? If I run this again, what happens? Only this particular cell, what happens? Let us see, okay? Only that cell. I'm not going to do anything else, only fit I'll do. See this here, 9353, right? I'll run this only. See that? Any change you saw? Do you observe anything here?
It started from the last learning.
Yeah, right? Again, if I execute, right? See 9539, right? Again, if I execute only this particular cell, see that it is starting from 95 again. Why is that happening? That's a very interesting thing. I think it's a simple thing but interesting. Why is that happening? Why is that actually learning from the previous left out number?
It's not reassigning the weights from
Yes.
the initial.
Yes, and very good. Right? What is happening there is that's the transfer learning. That's the transfer learning, right? We'll actually see transfer learning in coming class, right? This is the basis for it. So what is transfer learning is, the model actually started somewhere, learning theta somewhere here, right? By first time when I ran, right, it came till here maybe. Okay. Second time when I ran, it actually picked up these weights and started learning again. Picked up these weights and started learning again. So in memory, you have already trained weights are present in the memory. So it is taking those weights and starting from there. So we ran it thrice, right? If I give 60 epochs, right, I would have got 96% accuracy. I'm executing it again. If I gave 80 epochs, I would have got 97% accuracy or 96%. It is actually diverging, it's jumping around a little bit. If I run it again, right? So we actually saw a little bit of transfer learning there, right? You guys got it, right? What is transfer learning? You got it, right? We'll see clear example also on CNN, but if I give 100 epochs, right, I would have got 97% accuracy on the train set. Let me do that. Here, if I give 100 epochs, if you do 100 epochs in a single shot or learn multiple times, it is same. But I showed you multiple times because I wanted to show the transfer learning concept. Okay, I'm just kernel restarting and rerunning everything. So if you see, right, you will get 97% accuracy. But when you saw in machine learning, the maximum we got was 92% accuracy on the softmax regression classifier. Do you remember? Do you remember? The maximum accuracy we got on a machine learning model for this same data set is 92%. Do you remember?
Yes, sir. Remember.
So see this, that's the power of deep learning. So we are actually making the model complex by adding many layers and many nodes. Right? That's when the model is actually understanding better. Okay, there is capability in data, but the model was weak. See, 98% we are getting accuracy. See, there is one more point we need to remember. Depending on the version you are using, the TensorFlow version you are using, the accuracies will change. there will be some bugs. There may be some bugs. In 2.2 and 2.1, the code was not working. Right? I built this code in 1.4, and then I migrated it to 2.1 and other versions, 2.0 and 2.2, 2.1. 2.1 and 2.0, 2.1, 2.2, the code was not working well. Again, it started working well. So these guys actually changed. So 99% accuracy we got on train set. See, there is a method called a summary on the network, on the model we built. So this is the model, right? You can actually do summary right after it. No need to execute, but I did summary here. When you do summary, right, it actually shows you all the networks and all the parameters there. What are these? What are the parameters in a model-based learning?
Thetas.
Sorry.
Thetas.
Thetas, weights, right? Weights, right? Between the input layer and the first layer, 1,25,000, sorry, 12,560 weights are there. Is it correct? Can you calculate? How will we calculate this?
Input layer versus the first hidden layer.
Yeah, 784 input variables and plus one bias term, right? 785 into 16. Let me calculate that. So 785. Why am I saying 785? 784 pixels and one bias term into in the next layer. How many nodes are there? 16, right? For each node, you need 785 weights. For each node, you need 785 weights to create linear combination. Then substitute that into ReLU, right? So there are 16 of them. So that's going to be that many. So see that, right? So that calculation is needed because if you are unaware of how many number of weights are going to be created, these are all float numbers, and you are unaware of how much memory is needed to run this model, you will not be able to build models, good models. You may build a model that is very weak or very strong that cannot be handled by the memory in your computer. Got it? This is all for real time I'm actually talking about, right? While practicing, right? On Collab, you'll have everything. No need to worry about most of it. Right? Even on Collab, you'll have the memory issues, but right, most of it is going to be there because that guy will give around 16 GB of RAM and all that. Okay. So that is summary. Summary actually shows you how the network is structured and number of parameters and things like that. Okay. And then on test set, I'm evaluating. Evaluate is a method which actually takes, and then you got 90% accuracy on the test set. So this is loss and this is accuracy score, right? Evaluate method, this is loss, how much loss we have and how much accuracy, right? This is overfitted model. This is a overfitted model. So we have to apply some regularization. We'll see the regularization techniques and other, theory, right? The optimization objectives and regularization techniques tomorrow, theoretically, and then we apply them. I already applied something and commented out here. Okay, this is a overfitted model. We can bring this to balance. First goal of a data scientist or a AI engineer is to make the model overfitted, then bring balance to it, right? So that's about a first example on deep learning. Okay. Any questions? I'll stop it here because I need to download the content into Ubuntu. I did not do it. I just downloaded whatever is needed for now. So I'll download it now and keep everything ready for tomorrow.